Hello viewers. So today I'm having this very good problem from the SS Krotov, the problem number 3.4, and this problem is of course related to the chapter electrostatics. If you talk about guys problem, this problem is mainly I would say is having that analytical reasoning, very rigorous analytical reasoning is involved in this, okay, and mathematically it is way simpler, okay, a bit symmetry you can say is getting used here. So these are the some small you can say the elements that is needed to solve this particular problem, okay. I would say it is one of the good problem from the chapter electrostatics from SS Krotov, okay. And of course if you talk about IE Rodov and if you talk about SS Krotov, the Irodov is more like of course it also checks your the basics, the concepts, but along with that it checks your the uh, mathematical aptitude also, okay. You should be very good at the calculus, okay. You should know how to deal with the calculus, okay. So that is getting involved in the Irodov. But if you talk about Kroto, it is generally guys in the problems it uses simple algebra, okay. But if you talk about the physics that is going to be involved in this, is going to be way complex compared to Irodo, I say, okay. And that's why I think this is very much advised to the people who are preparing for INPHO and IPHO, okay. And now like IOQ, this new name has been came, but I like to call that INPHO only, okay. So of course it is really like good book and advice for the people who are preparing for INPHO and IPHO, okay. So without any further ado guys, let's come to the question. I'll just formally once read this question for you, and then we'll start discussing this problem. So guys, here if you see, the question says that the strength of the electric field produced by the charges uniformly distributed over the surface of a hemisphere at the center O is E naught. A part of the surface is isolated from the hemisphere by two planes passing through the same diameter and forming an angle alpha with each other. Determine the electric field strength E produced at the same point O by the charges located on the isolated surface, basically on the Merry-Karp. Okay, so Merry-Karp guys, this is some you can say kind of a term that is maybe used in the old days. I don't know nowadays we use it or not, but in that time guys, I think they use this idea of Merry-Karp. What is this Merry-Karp guys? Okay, if I try to draw this, so it will something guys look like, if you see, I will just try to show you, okay guys. So if you see, so guys, this is the Merry-Karp, okay. If you see guys, this is your convex portion, okay. This is the convex portion, and this is what the concave portion, okay. Something like this would be guys known as what, a Merry-Karp. If I say, if you take any watermelon, okay, if you take any watermelon, and when the the shopkeeper cuts that watermelon into small pieces, okay, like in the direction of diameter, then guys you see that there is a portion that comes out something like this, okay. This kind of a portion comes out. If you see, these kind of a portions come out, okay. So guys, this is nothing but, and here you have of course your the pulp is there, okay. So if you remove this pulp, you forget this pulp, this layer guys, this layer is basically is one of the Merry-Karp, okay. So I hope I have talked about a little bit about that what we are trying to talk about here. So here guys, if you see, this Merry-Karp will be having the positive charge, let's say, on this surface also, okay. If you talk about, Okay, this surface guys, if you see, if I make it properly, this surface, okay, you getting my point guys? Okay, this surface, and similarly guys, you will be having the charge on the other portion of this also guys, which is lying on this surface. Okay, I'm hoping you are able to visualize that what is I'm trying to talk about here. Okay, so guys, they are interested in to find the electric field due to this portion only. Okay, due to this portion, guys, this merry curve. Okay, this merry curve, if you talk about, due to this guys, at the center, what is the electric field is going to be, that they are interested to find. Okay, so of course, if we discuss about this problem guys, it is not going to talk about much of a math. It's a very basic math, but a lot of symmetry and the idea of like the logical reasoning, all these things are involved in this particular problem. Okay, so without any further ado, let's see the solution guys. So guys, if you see this view in which this picture has been presented, this view is guys known as isometric view. Okay, this is known as what? Isometric view, basically the 3D view. Okay, the 3D view of this particular problem. But guys, to understand this problem in a better way, what we are going to do, I'm going to show you the front view of this problem, basically the sectional view. Okay, so if I draw the sectional view guys, for that I am making a circle here, and then I'm going to make it half of the portion so that I can show you the sectional view of this. So guys, for that, let's say I am cutting like this portion, and here I'm just meeting this. So guys, this is a hemispherical portion of this. Okay, so if you talk about the Mary curve portion, okay, this Mary curve that we are talking about, this is guys, this is subtending an angle alpha here at the center. Okay, this portion, if you talk about this portion of the Mary curve. Okay, this portion, this is the front view guys. The back side will be also the same part will be there, like this way. Okay, I hope you're getting my point. And then guys, of course, there is a remaining portion is also there, this portion. Okay, this portion, this is a bigger Mary curve, you can say. Now what they are asking that the field due to this portion, the field due to this portion guys. Now if you see guys, the field direction, if I ask you, the field direction would be simply guys, if you see, the field direction will be in this direction only if the charge is what? Positive. Which will be what guys? Along the angle bisector. Which will be what guys? Along the angle bisector. If this angle is alpha by 2 guys, then this will be, because guys this will be also what? Alpha by 2. So this will be what guys? Alpha by 2. So guys, if you see here, what we can say, this is the direction of electric field that we want to calculate. This is the direction of electric field that we want to calculate. And maybe some of you might ask that why sir this is the direction. So guys, if you have studied the electrostatics, you have seen the what the electric field due to the circular arc. Okay, if you calculate the electric field due to arc, you see that if at the center you calculate the electric field that comes at the center, just going away or inward due to that arc, and it always passes through the what? Angle bisector. And this Mary curve also guys, if you see, it is nothing but what? The collection of multiple arcs. Okay, it is nothing but guys what? Collection of what? Multiple arcs. Okay, and these kind of a arc would be there guys. When you connect all these arcs, you will having this Mary curve. So using that idea, okay, if I extend that idea, I can say for sure that electric field will be what? In this direction only. So I'm hoping till this you are with me. Okay, so now guys, if this is the smaller Mary curve, and it is forming the electric field here guys, E in this direction, then the similar way guys, for the remaining part of the Mary curve, which is the bigger Mary curve, if you talk about, which is here guys, it will be also creating some electric field, which will be also what guys? At angle bisector of this, something like this. Okay, let's say guys, this I am calling as E dash. So guys, because this whole angle is what, 180 minus alpha. So guys, if I ask you what is this angle, this angle will be simply guys what, it will be 90 minus alpha by 2, 90 minus alpha by 2, because half of that angle bisector, because it is guys. So this will be also what guys, this angle, because these are what, the opposite angles. Okay, so guys, this will be what, 90 minus alpha by 2. Okay, now if you see guys, these two angles will be what, same only. Now if I do the components of these two electric fields E and E dash guys, so if you see what I'm going to do, if I do this E dash component guys, so this will be what, it will be E dash sine 90 minus alpha by 2, and this will be what guys, this will be E dash uh, cos 90 minus alpha by 2. I hope you are with me guys till this. Okay, similarly guys, if you talk about the E, the second one, okay, that we want to actually calculate, this guys, this angle is how much, alpha. So guys, this component will be how much, it will be E cos alpha by 2, and this will be what guys, E sin alpha by 2. Now guys, if you talk about the electric field that we are having due to the hemispherical shell at the center, we know that guys, this comes either outward or inward along this axis. Okay, it will come outward or inward along this axis, and that value we also have calculated, that is sigma upon 4 epsilon naught in the problem 3.3. Okay, I had discussed this problem earlier in this series only guys. So it means guys, the electric field that is going to be there is going to be along this axis, but in the horizontal direction there should be no electric field. Okay, in the horizontal direction there should be no electric field. So it means guys, if you talk about this whole portion guys, if you talk about this Marikarp and this Marikarp, so using the superposition theorem I can say it will be forming the hemispherical shell only. So if this is forming the hemispherical shell, the net electric field should be in this direction only guys, along this direction and this direction guys, there should be no electric field. It means all the horizontal component that we are having, that should be equal to what guys, 0. So using this idea, what I can say, I can say that E, I'll change the color guys, E cos alpha by 2 should be equal to what guys, E dash cos 90 minus alpha by 2. So guys, from here what we will get, we will get E dash cot alpha by 2 is equal to what guys, E dash. That is the first equation that we need. And now guys, if you see in the vertical direction, which is this direction guys, the electric field that we are having is having two components, and that E naught guys, because that is the net electric field that we are going to have, that E naught is basically the sum of what guys, E sin alpha by 2 plus E dash cos alpha by 2, because sin 90 minus alpha by 2 is equal to what guys, cos alpha by 2. Now if I guys drop E dash value from here, then I can get the E very simply guys. So if you do that guys, what you will be having, E naught will be E sin alpha by 2 plus E dash, sorry guys, I have to replace this. So E dash will be what guys, E cot alpha by 2 into cos alpha by 2. So guys, if we do little bit simplification here, so E I can take common guys, so sin alpha by 2 plus cos square alpha by 2 divided by sin alpha by 2. So guys, if we do the math, it will become E naught E sin square alpha by 2 plus cos square alpha by 2 is equal to 1 guys, and it will become 1 upon sin alpha by 2. So guys, E will be simply E naught sin alpha by 2. E naught will be guys, sorry, E will be what guys, E naught sin alpha by 2. So if somebody asks you guys also, let's say that due to the quarter shell, okay, the quarter shell, what would be the electric field? So guys, that would be very easy, because we know that E naught is simply guys what, sigma upon 4 epsilon naught, and guys alpha in that case will be what guys, 90 degree. So sine 45, okay, the sine 45, that is what, 1 by root 2, that would be the electric field, guys. And to check that, is the E is going to be E naught? Answer is, guys, yes. If alpha would be what, guys, 180, and if you put 180, guys, it will become what, sine 90, because sine alpha by 2 is what, guys, sine 90 is going to be there, and of course E is going to be, guys, what, E naught. So that cross verification also we can do it here, okay. So all this justification is happening, and this would be what, guys, your answer. So if you see, guys, this is a simple algebra that has been involved in this problem, but guys, so much, like what, the reasoning, the superposition theorem, the symmetry, all these ideas have been used in this particular problem. So that's why I say this is one of the good problem from the SS Krotov. Okay, guys, so that's it. Thank you so much. I'll see you in the next problem. Okay.